My Recon in 2026 is completely different. I open the platform I will hack on, I choose my target, I read the policy, I check the scope, I open the main app, and I start hunting. That's it. That's my Recon. I know what you are thinking. Is he lying? Is this even real? Does he actually skip the Recon, or is this just a content angle? Let me prove it. In this video, I will show you exactly what I do now for every target every time. And by the way, while prepping for this episode, I challenged myself to do exactly what I'm about to show you in this video. Only 2 days, 5 hours each on one public program as the target. The exact process, no classical Recon, nothing else. And here is the result. Stick around so you know exactly how I got here. So, this is AmrSec, go get your coffee ready, and let's dive in.
The channel has enough content.
As this is like, look, download that in podcast. I used to do all of it. Subdomain enumeration, host discovery, HTTP propping, take fingerprinting, JavaScript scrapping for secrets, wordlist content brute forcing, the full chain every time on every new target. I would spend 3 hours building a spreadsheet, subdomains, technologies, exposed surfaces, maybe a few interesting endpoints. 3 hours of setup before I even looked at the actual app, and most of the time, at the end of those 3 hours, I had nothing. Not sometimes, usually. And when I say nothing, I don't mean literally nothing. I might find a misconfig here, a tick banner there, some low severity stuff, but not the real bugs, not the high impact ones, not the bugs that actually pay. So I started asking myself a question: where do the bugs that actually pay actually live? Not the informational ones, not the duplicate ones, not the stuff that closes as intended behavior. I mean the real bugs, the ones that a user wants to talk to you about. And the answer was the same every time. They live on the main app. So why the main app specifically? Because that's where the complexity actually lives. The feature flags, the user rules interacting with each other, the access control logic getting evaluated in 100 different places, the business logic that company actually ships and updates every week. That's where the decisions are, and complexity plus decisions is where bugs live. Always. I'm not saying other parts of the attack surface don't have bugs, they do. A forgotten subdomain can have a tick misconfig, and all the API can leak data. Those are real findings, but if I have to choose where to spend my first hours, I start with the density of real business logic bugs is highest, and that density is always on the main app. On almost every target I hunt, I find the broken access control somewhere on the main app, constantly. IDORs, privilege escalation, row confusion, horizontal access failures, almost always there, always reportable, and always paid. Now in Recon, most hunters talk about two things: asset discovery and content discovery, and they treat those two like they are the whole job. Asset discovery is finding a new surface, new subdomain, new host, new things the program forgot about. But content discovery is finding a specific thing in a specific place, hidden endpoint, backup file, old routes, undocumented parameter, etc. I skip both, but I want to be honest about why. I skip asset discovery because I don't need more assets right now. They would just distract me. The host I'm hacking on is already in front of me in the browser. I picked it when I picked the target. If the app is communicating with another host, my proxy shows me that the moment the request fires. I don't need a scanner to tell me what the app is doing when the app is telling me as I use it. I skip content discovery for a completely different reason. Content discovery only makes sense when you know what you are looking for and why. Before I have understood the app, I don't. I would be fuzzing for directories. I have no reason to want or brute forcing parameters I couldn't tell you the purpose of. Why would I do that? If I can't answer why am I searching here and what am I searching for, there is no reason to search. But later, if I am on a specific bug and I need a specific thing, that's different. Let's say I have an authentication issue that only becomes critical if I can chain it with an open redirect, for example. I don't have an open redirect yet. Now I go do content discovery at this exact host looking for parameters that takes a redirect URL Or I'm hunting for a data explosion and I need a backup file to prove the impact. Now I go look for one, targeted, one specific place, one specific reason, driven by my understanding of the app, not by the habit. That's the difference. Content discovery at the start is guessing. Content discovery after understanding is hunting. The place the bugs live is already sitting open in your browser. The faster you start looking at it, the faster you find things. So now you know where to start. Let me show you how. Before I explain anything, I just use the app. 10 minutes. I log in, I click around, I hit every main feature I can find without thinking too hard about it. I don't test anything, I don't change anything, I just use it like a normal user would. And my proxy sits in the background recording everything. I know you might have heard the use the app first advice before. Stick with me. What comes right after it where it gets different. 10 minutes later, I have two things, a feel of what the app actually does and a clean pile of real traffic sitting in my Kaido HTTP history. Then I split. A normal platform with one kind of user splits into two pieces, the front end and the back end API. Everything the browser renders is one surface. Everything requests talk to is another surface. 2. If the platform has more than one kind of user, the count can multiply, but only when those rules actually ship on separate apps, meaning fully separate product, a partner portal that lives on its own URL with its own front end and its own API, an admin panel built on its own interface, not a page inside the main one. If you have a regular user app and a partner portal, each with its own front end and in its own API, that's 4 pieces. Add an admin panel on its own stack, 6 pieces. Here is the thing nobody catches. The multiplier is not the number of roles, it is the number of separate apps the platform ships. You can have 10 user roles and still live on one front end and one API. This is still 2 pieces, not 20. Same URL route, same backend, just different access decisions happening inside. Rules matters for what you test inside each piece. Surface matter for how many pieces you split into. So when you count ads, not rules. That's the split. And the moment you run it, everything changes. You stop looking at a target and to start looking at a finite list of surfaces. A photo sharing platform with user account and partner dashboard. It's not one thing, it's 4 things. 4 places where access control can fail. 4 places where the developer probably did not remember to enforce the same rules across every boundary. Every piece gets its own attention. Every piece gets its own session. You never mix them up. You never forget one. That's what the split gives you. Focus before chaos. So now you have got your pieces. Let's talk about what you actually do with them. Most hunters understand how an app works. They read the docs, they click around, they figure out what the features are. That's the floor. It's not enough. You need 3 questions answered. How, why, and when. How does the feature work? Everyone gets there. That's the easy one. Why does it work? Why is this field here? Why does this endpoint return what it returns? Why does this user see this button and the other user doesn't? Why is there an admin role at all? And what does an admin sees that I don't? When does it work? When does the check fire? When does the permission get evaluated? When does the server trust the client? And when does it not? When does the rule boundary matter and when does the code forget? Those 3 questions honestly answered gives you the full picture. You know who has what privileges, you know how the admin interacts with the regular user, you know where trust sits and where it breaks. And once you truly understand all 3, you have really found bugs. You don't need a separate testing phase. The bugs show up as gaps. The places where the developer assumed one thing and the server trusted another. The place where the permission was checked on the front end and forgotten on the back end. Those places don't hide from you once the app is clear in your head. That's the whole game. Confused hunters find nothing. Hunters who understand find everything. Let me walk you through what that understanding actually looks like, step by step. First, I look at how the app talks to its backend. Is it REST? Is it GraphQL? Is it something custom? Some internal RPC the company wrote themselves? I open Kaido, I load the HTTP history, I scroll through the traffic my 10-minute browse already captured. That alone tells me the shape of everything that comes next. Then I check who the API is actually for. Let's say it is GraphQL. Is this one API service both the regular user and the admin role? Or if there is a separate admin endpoint sitting somewhere I haven't seen yet. If there is a partner endpoint that looks the same but trusts different input, two identical looking endpoints with different trust boundaries is where the bugs are. Then I go to the features, not all of them. I pick the interesting one first, the one that touches the other users, the one that share data, the one that let me invite, upload, or publish. Every interesting feature has options and every option is its own test. Let's say the platform lets you share a photo. You get 3 options: public, link only, not browsable anywhere in the app, and password protected. 3 completely different trust models in one feature. Is the password check happening client side or server side? Is the unlisted link actually unlisted, or if there is a listing endpoint somewhere that returns it anyway? Is the public photo really public, or does it leak metadata it shouldn't? 3 options, 3 separate investigations. While I'm doing this, anything interesting I see, I stop and I capture it. So let me tell you what counts as interesting. Anything that breaks the normal rhythm of the app, a UI element that flashes on screen and disappears before you can read it, a button that only shows for a split second during a loading state, a request that returns more data than interface actually displays, a response that comes back faster than any other call or slower, a field in the page that renders a value you didn't provide, a header in a request that you never saw on any other request, an endpoint that responds differently depending on when you hit it. These are the anomalies that carry bugs. Capture them now, move on, and come back later. I take a screenshot. I write a 3-word note: admin header present, user ID twice, client side permission check. Then I keep going. That note is not a to-do list, it's a map. By the end of the exploration pass, I have 20 notes. Every one of them is a candidate for a real test. Then I test. And the testing is not random. The notes tell me what to do. The understanding tells me what to try. That's the loop. Use the app, read the traffic, count the pieces, walk the features, know the interesting, test with intent. When the app is confused, we get bugs. Hold that line, it's the whole mindset. Here's what I mean. Classic testing says change your user ID to someone else's user ID and see if you get their data. That's the first thing every hunter tries. Every developer knows to block it, usually fails. Most hunters stop there. I don't, because the real bug is not always in the direct ID swap. The real bug is in what happens when you feed the app a value the developer never expected. Your ID as null, your ID as undefined in JavaScript apps. The victim's ID drop into a field that was never meant to hold a user ID at all. And watch this one carefully. If I can't change my ID and see the victim's data, fine. Every developer blocks that. But what if I publish a photo where the publisher field is already the victim's ID, not my ID swapped with theirs on my own profile? Their ID in a field that was never supposed to accept my input. Maybe my photo now shows up on their profile. Maybe when someone reports that photo, the victim gets the email. Maybe the permission system now treats them as the owner and me as nobody. Maybe sharing that photo pulls the victim contacts through a chain nobody designed for. That's the creative move. You are not trying to bypass a check. You are trying to feed the app requests it doesn't know how to categorize. When the app is confused, we get bugs. Because confused code doesn't know which rule to apply. Confused code takes the path of least resistance. Confused code trusts the nearest value it can find. Every one of those resolutions is an unattended behavior the developer never thought about. And look, I'm not telling you to hunt IDORs specifically. I love broken access controls, but the message here is not go hunt IDORs. The message is that understanding what you are dealing with without getting confused yourself is what makes these bugs show themselves. You stop hunting for idols as a payload you throw at a thing, and you start hunting for confusion. Stop trying to bypass one check. Start trying making the app unsure which check to run. Do this enough times and something shifts. Understanding the app builds a library in your head, not a payload list, a library of buttons. Here is 3 examples of what I mean. When I see a permission panel in the interface, I think broken access control. I don't pull up a checklist, the button fires on its own. Who can invite? Who can kick? Who can change rules? What happens if I swap the rule value on my own request before it leaves the browser? When I see any field that accepts a URL, a webhook destination, an image uploaded by link, a video fetched from a URL, I think SSRF. The button fires. What does the server do with that URL? Does it follow redirects? Does it accept localhost? What headers does it send? What happens at internal addresses? When I see a user controller input reflects back into the page, I think full range of injection and access techniques. The button fires. Is it an attribute? Is it in a script context? Is it escaped server side or client side? Where does this string end up? Downstream. 3 buttons, 3 completely different bug classes. None of them requires a payload list. All of them requires understanding the feature well enough to recognize what class of bug lives there. That's the whole point. The more targets you understand, the bigger your library gets. The library is real skill. The tool chain never was. And nowhere does this matter more than when the app tries to look complicated. Developers are human. They write obfuscation that looks scary and isn't. They add layers that look complicated and aren't. If you don't read the code, you will believe them. Let me show you 2 patterns that fool automated tools and don't fool anyone who actually reads the code. First pattern, base64 encoded user IDs. You hit an endpoint. The user ID in the request is not a number, it's a long base64 string. 50 characters, maybe more. It looks cryptographic. It looks like something you shouldn't touch. Decode it. It's just your ID wrapped in base64. That's the whole mystery. Now change the value, re-encode it, send it. You just swap to another user. Automated secret scanners don't cache this because it is not a secret. It's the real ID just wrapped in one layer of encoding. It looks dangerous until you spend 3 seconds reading it. Second pattern is a signature that lives in the JavaScript. You try to hit an admin panel. You get 403. You dig into the failing request and you notice the admin request includes a custom header, something like x-admin-signature. The value is long hash. If you didn't know the algorithm, you would assume there is a secret key sitting on this server. Open the JavaScript file, the main app is already loading in your browser, search for that header name, and there it is, right in the source. The signature is SHA-256, hash of 3 values, your user ID, your user agent, your username. All 3 you already have. You compute the hash yourself in 3 seconds, you set the header, and the admin endpoints open up. Because the server never actually checks that you are an admin, it only checks that the signature math is valid. No server-side secret, no key you need to steal, just auth logic the developer put in the front end hoping nobody will read it. They assumed the signature alone was proof of admin access. It was only proof you can compute SHA-256. An automated scanner will never find that. Scanners look for strings like AWS_secret or API_key equals. They don't look for auth logic encoded in front-end code. Reading finds it. Scanning doesn't. What developers think is hard is usually not hard. It's hidden behind one layer of encoding or one function call in the source. Read instead of scan, and the whole class of obfuscation becomes trivial. Which brings me to a bigger point about JavaScript. Old Recon taught you to collect every JavaScript file the target loads, save them, run scanners on them, grab for secrets. That's still what most hunters do. I stopped, and here is why. If I am hunting on xyz.com, then xyz.com calls its JavaScript files every single one of them. When I browse the app with Kaido sitting in the middle as my proxy, every request to every JavaScript file shows up in my HTTP history already without me doing anything. So I don't need a collector, I don't need a crawler, I don't need a bulk downloader. I use the app, open Kaido, and every JavaScript file the app actually loads is sitting there, ready to read. But the collection question is the easy part. The harder question is what you are even looking for and why. Take PII for example. That's a classic target for the old-school JavaScript scrapper. You run tools that look for email buttons, phone number regex, hard-coded credential in JavaScript strings. You hope you get lucky. But here is what I do instead. I go through the sign-up flow slowly. I enter my email, my phone, my name, any data the app asks for, and I watch every single request my proxy records. I see exactly where my email goes. I see exactly where my phone number lands. I see which endpoint returns user data to which role under which conditioning. 20 minutes later, I know the entire data map, where the PII lives, which endpoint expose it, which role should and shouldn't have access, and any gaps in that map is a PII leak I can't test directly. The bulk scrapper never finds that. The bulk scrapper is looking in random pieces, hoping. I'm looking at where the data actually moves. That's the trick. Understanding the flow beats scrapping the files. Every time, every target. What I care about is the real bug, the one that took understanding to find, the one that rewards the time I put in. I just spent this whole video talking about Recon, understanding the split, confusing the app, reading JavaScript. I didn't mention OAuth. I didn't mention authentication flows. I didn't mention session logic. And that's on purpose, because that's an entire world of its own. Auth bugs are some of the highest paying bugs in any program. Every minute you spend there is worth it. But it's not this video. Maybe the next one. If you want me to go deep on the auth side, drop auth in the comments. If enough of you want it, I build it. That's how I do Recon in 2026. No subdomain enumeration, no wordlist spam, no JavaScript collectors, just the app, my proxy, and my head. Understanding beats scanning every time. I know this video is shorter than the most Recon videos you have seen. That's on purpose. I would rather give you something you can actually use than bad out the time. If this changes how you start even one target, if it saves you time, it did its job. Now I want to hear from you. If you do it differently, drop your actual process in the comments, not theory, what you actually do the moment a new target lands in your lab. I read everyone because the best hunters I know all approach this a little differently, and I learn from every one of them. So if you find this video helpful, do not forget to like, subscribe, and hit that bell icon for more cybersecurity content. And if you have any questions, feel free to drop them in the comments below, or you can reach me directly on X. Until next time, stay curious and stay secure.